You can certainly have a line in 3D. Lines are in 3D, right? Does anybody here play with VRs? Thank God. I love my VR. And I'm actually told that like younger people play with it. My mom was really fun on that. I put it on my mom. She's like, you go there. Like, Mom, you're not there. It's on your head. I'm recording this. Hope she doesn't watch it. In 3 dimensions, you could have lines, like first-person shooter games that are 3-dimensional, and in the VR, you're shooting something. They're using 3-dimensional vectors to do that. That's exactly how they're modeling it. And so a line in 3D is P of t equals position plus t times v. That's why we do it. It's the same old thing, same model. In Cartesian coordinates, it is not so. It is an ugly beast. And you can do the same thing. Cadet Wong, was that your work? What's your first name?
Chris.
Chris, you can do the same thing to get the, like, they call it, what you did is called the symmetric equations. So let's do an example with numbers. Well, I do vertical vectors. Does she do vertical vectors like in vertical form, or does she always do it sideways?
Sideways.
Okay, you can. It's actually more appropriate to use vertical, but I'll leave it alone. You have enough torture. Okay, so one of the reasons I studied the way I did, which I'm asking you, please don't do that. It actually is simple, and all of you can learn the geometry. I am not special. I've just been doing this a long time, and if I can learn that, everybody's capable of learning this. So this thing here, the way we draw things in math, is we have x, y. Your old Cartesian plane that was drawn on a blackboard is now on the floor. So this xy plane is now on the floor. What was your x going across is now coming out at you. And what was your y, that was your vertical axis, is now flat on the ground. And this thing is z. And this is the only time I'm going to say pain does it right. Physics does it right. Physics has the z coming out towards you, and the xy stays on the board like you're used to. That's the only thing I think physics does right. I'm being recorded. I don't care. So that's how they think of it. So what if I have a vector like 4, 5, 6? How do I draw that? I start at the origin. This is my origin. 4 is in the x. I'm going to take 4 steps to the front. 1, 2, 3, 4. That's the 4. 5 goes to your right, my left. 1, 2, 3, 4, 5. So when I draw this on the blackboard, it's really good that I have a movie of it. 1, 2, 3, 4 would be the 4 steps in the front. 1, 2, 3, 4, 5 would be to the right. And this point on the floor would just be the 4, 5, the location of that point. This Z is the elevator. It goes up floors. So here I go 4 to the front, 5 to the right, and now up 6 floors. So pretend I could lift up 6 floors. I did try that. I couldn't lift up 6 floors even when I had something to hang on. But that's what you're doing, is you're just climbing up 6 flights, 6 floors. And so that would be up in the air. 1, 2, 3, 4, 5, 6. This thing would go up in the air like that. So this is the point 4, 5, 6. That's how you should think of it, drawing it in math. And then from the origin to this tail point, origin to that tail point up in the air is this vector that shot up from the ground up. Is that okay? You do have to imagine this. So my teacher used to say, make phony pictures in your head. That's one of the reasons I'm like, I'm just going to convert it back to X, Y's, like what I know. I'm not listening to you. I don't know what you think in your head. I don't want to know. But that's what I think he was trying to tell us. Like, you have to kind of think about this, even if you can't draw it. Okay, so now I could do the same thing. I got this vector out, shooting out this way. I could stretch it in both directions. So this is the stretch factor that stretches in both directions. Now I could force it to go through the point 1, 2, 3. So 1, 2, 3 is here. 1, 2, 3. I could lift this vector up and force it to go through that point. Same as 2D. No different. The geometry is exactly the same. Do I have questions for you on that? On your sheet? Do I ask you something about it? We're going to move on to planes because otherwise we're not going to get through anything. Questions?
Is there an easy way to like think about like which way is X, which way is Y?
Yes. You can say those dumb butts, I won't use it, those dumb butt mathematicians took the blackboard and put it on the floor and took the direction that we would have thought was the cross and put it out at me. So I don't know, like you just have to kind of think like for math, it's like that. So if you're going into engineering, they actually have Z coming out at you. That's the natural way, right? We had just everything on the blackboard, and then the Z should be the new dimension coming out at you. That's the right way. So maybe we shouldn't say physics does it right. Maybe we say engineering does it right. That's unfortunate. So there's no way to I don't think there's any easy way other than we messed up. We royally messed up, actually, because it would even have been better if Y was coming out at you, right? Because Y was the vertical axis, and like if the floor is really the floor, the board would stay the floor. The Y should have been coming out at you. We royally messed it up. I wonder why we did that. Okay, I'm going to move to I have like board problems for you. We're going to skip that and go to the plane, or else you guys are going to be hurting for your homework. Anybody started in here? Not yet?